Started. Yep.
Mm-hmm. Yeah, so hi everyone, a very good morning and welcome to MuleSoft Mysore Meetup group. Today we have our speaker Shivani who is going to talk about transaction management in Mule 4. So yeah, very important aspects to know like how you can manage your transaction. Uh, can you move to other slide, Shivani?
Yeah,
So yeah, this session will be recorded for your future reference. So you can check out our YouTube page or Meetup, Mysore Meetup group page, to find the recordings. And feel free to unmute yourself and ask a question anytime, or you can also put your question to the chat box. So before we start, let's know about the organizer of Mysore Meetup group. So we have Shivam here. He is currently working with Bilinium as a integration developer, and we have Giridhar, who is currently working with Hashdin as a technology architect. So, and here I am, Priya Shah. I'm currently working with LTI Entry as a senior software specialist. Yeah. So now let's know about our speaker, and then we can get started with the agenda of today's topic. So, Shivani, you can start.
yeah. Hi everyone. Am I audible?
Yes, you are.
Yeah.
Okay. Yeah. Good morning, everyone. I'm Shivani. I am working at Ashton by Deloitte as a MuleSoft developer. I have 4+ years of experience with MuleSoft. I've worked on various phases of API development, like design, developing the API on Anypoint Studio, and deploying and managing it in the Anypoint platform. I've worked across various projects, and I am a MuleSoft certified developer. I also hold an active MCIA certification. So you can find my profile on LinkedIn as well. Yeah. So that's about me. Um, yeah, we can proceed with the agenda, I believe.
Yeah, Shivani.
Yeah. Um, so today's topic of discussion is transaction management. So we'll have an overview of transaction that helps us understand what transactions are, what mule transactions are, and then we'll talk about type of transactions, local and global transactions, and post which we'll discuss about the transaction protocol and the mule transaction actions, and then we'll have a hands-on demo with transactions through DB connector, and we'll discuss a little bit about the usage of Bitronix that is provided by MuleSoft to manage transactions. Post which we'll have a small networking session and a Q&A session. So, without any further ado, let's proceed with today's agenda. So, first of all, let's talk about what transactions are, right? So, anyone wants to pitch in here? You want to, talk about, what your understanding is about transactions? Anyone?
Guys, don't hesitate to speak anything what you feel, what you know about transactions.
Okay. To put it, let me give you a simple understanding. So to put it simply, a transaction is nothing but a set of operation that has a definite result, right? So in real time situations, you use many websites, right? You use e-commerce websites for online shopping. You use again internet for banking purposes, for booking tickets. So there are a lot of use cases for which you cannot expect the system to give you an um, undefinite response to you. Let's say you're in the middle of the booking and something wrong happens. Let's say the payment has not happened successfully, or let's say you lost your internet connection in between. So you can't expect the application to, stop abruptly and leave you hanging, right? So you want it to complete no matter what situation comes in between. It has to complete and give you a definite response. So put it simply, a transaction is nothing but a set of operation that will have a definite response. It can be either a success response or a failure response. Okay, so in terms of MuleSoft, you have various event processors. In Mule 4, you have various event processors. So different event processors in a flow perform a functionality, right? So if you want to consider these event processors to work as a transaction, then you do some specific configurations, right? You put them in a try scope, so you do some configurations to make them work like a transaction, so that at any given point in time, whatever response they're giving the end user, it is not a undefinite response. It should be a definite response. Okay, it should either be a success response or a failure response. So are we clear with what transactions are? So basically, anything that fails or succeeds as a unit is called a transaction. So nothing in our day-to-day life is not a transaction. Everything is a transaction that you do. It either has to fail or succeed as a unit. So it's important that we carefully work through this in whatever real-time applications that we are building. Um, so are we good till now? Any questions? Any more examples that you would like to know about transactions? Okay, so I'll take it as no questions. So moving ahead, we have transaction types. Okay, there are different transaction types. So we have local and we have global transactions. Okay, so uh, so this is a flow, right? Usually a MuleSoft flow looks like this, wherein you have a source component and you have multiple event processor components that perform a functionality. Okay, now these event processors can interact with various external systems, right? Let's say in this case, there is an event processor, and this processor is interacting with an external system. Let's say it is a database, right? So in case your event processors in the flow are referring to a single resource, okay, so in that case we call it as a local transaction, where your functionality is spanning across one resource. So in let's take a real life example. So let's say you have a database. Okay, you have a database of e-commerce. Okay, e-commerce database, and inside e-commerce database, let's say you have different tables. You can have products, you can have payments, you can have orders, you can have different tables, but all of these fall under the same database. So event processors can interact with different tables, but they are all interacting with the same external resource or the database, that is e-commerce. So any set of operations that are spanning across one external resource are called as local transactions. So any questions with respect to local transactions, guys? You can also give me a thumbs up if you are understanding.
I think it's good, Shivani. I can able to understand.
Yeah. Okay. Yeah. Thank you. Yeah. So that is a local transaction. So generally, local transactions are easy to maintain. Um, they are easy, they're very good at performance. So they're easy to manage as well. Okay, since you are only dealing with one resource, you will not have, any complication in maintaining the consistency in that resource. Okay, so local transactions are simple, they have good performance, and they are easy to manage. But coming to a real world scenario, it's not always that you use only one resource, right? You can have a flow in which a processor, in which the event processors that are a part of your flow can interact with more than one resource. Okay, let's say you have two database instances. Okay, and one event processor is maintaining is interacting with one resource, and another event processor is interacting with another resource, okay, for whatever purpose, for modifying the resource, or for fetching details from the resource, whatever the reason could be. So the event processors are talking to um, multiple resources, right? In this case, how do you make this entire flow work as a single unit? Okay, so just think of the situation. Okay, let's say your event processor 1 is interacting with orders database. Okay, and event processor 2 is working with, sorry, orders table, and processor 2 is working with payments table. So let us say the processor 1 has successfully performed its action on the orders table. Okay, that part is successful. Now, coming to the second processor, we have the payments table. However, the payment is not successful. Let's imagine this scenario. Then, how are we going to make it work as a single unit? Okay, so here, placing an order and completion of the payment both should work as a single unit. Okay, if the payment is not successful, then this entire functionality should fail, and if the payment is successful, then it should succeed as a unit. But if they're spanning across two resources, okay, let's say your orders table is in one database and your payments table is in another database. Okay, so two tables across two databases, so two different resources that your processors are dealing with. So how do you maintain consistency, or how do you make it smoothly work as a single unit? Okay, so that can be achieved using a protocol. Okay, so it is called two phase commit protocol. Okay, so since your event processors are spanning across multiple resources, managing it would be a little complicated compared to local transactions, and also the performance of the flow is little slower compared to your local transactions. Okay, because two phase commit protocol is little bit tedious. I mean, it takes time to commit to reach to an eventual success or a failure scenario. It does multiple checks. Okay, so if you are clear with local and global transactions, let us move on to the transaction protocols.
Shivani, just like my understanding, so here the global transactions you are referring to the extended architecture, which sometimes called the XA transaction, correct?
Correct.
Okay, okay, okay.
Yeah. So this is also called XA transactions, yeah, extended architecture transactions, in which the functionality is spanned across multiple resources, not just one resource.
Yeah, thank you.
Okay. So now coming to the transaction protocols, right? So I was talking about two-phase commit protocol. So this is the protocol that we use to manage the global transactions, also known as XA transactions, extended architecture transactions. So the two-phase protocol is also called as XA protocol, extended architecture protocol. So it has two phases. One is prepare, and the other is commit. Okay, so you can see that there is one. So so this entire transaction manager component, resource managers, whatever you see, these are present in your Mule applications. Okay, the logic or the components are present in your Mule application. So these three are your Mule applications, and these are the independent external systems that you are referring to. Okay, so for every resource, like resource 1 and resource 2, you will have a respective resource manager. Okay, so let us say um, uh, an operation has to be performed on resource 1. Okay, so it will come to the transaction manager, and then it will go to the resource manager that is corresponding to the resource 1, and whatever operation has to be performed will be done. Okay, and then once the operation is performed, it will be in prepare phase, wherein the results of that particular operation are stored in a local storage, like you can store it in a file or something. Okay, so that is again the job of the resource manager as to where to store that operation. Then you have the resource manager corresponding to the second resource. Okay, so whatever operation you want to perform on the second resource, you perform it, and if it is successful, it will temporarily store that. Okay, it will be in prepare. So once these two are successful, then a commit operation is performed. Okay, so these two are managed by the transaction manager. Now, in case any of this operation is failure, like either if the operation is failed on resource 2 or resource 1, then the commit phase doesn't happen. Okay, so that is when the entire transaction is rolled back. And this transaction manager is also a part of your Mule application. Okay, so this is how we try to manage consistency in case of XA transactions or global transactions. So you can see that there are multiple interactions. You're not directly interacting with your resources in this case. You have a transaction manager, then you have a resource manager, and then you are waiting for all the resource managers to send a success response to the transaction manager saying that the operations are successful. Only then the commit phase is taking place. So the performance of the global transactions or XA transactions is slower compared to a local transaction. Okay, so this, in simple understanding, this is called two-phase protocol. Okay, if you like I already mentioned, the resource manager is nothing but your Mule application, the logic that you have written in your Mule application to interact with the resource. Similarly, the resource manager for the second resource is also created in Mule application only, and the transaction manager is also the logic that is built in your Mule app. Okay, so you have to have this architecture implemented in order to maintain consistency across the global transaction that span across multiple resources. So any questions with respect to two-phase protocol? Okay.
Nothing, Shivani, here.
Yeah. So if you're all clear, let us move to MuleSoft transactional actions. So based on these transactional actions, we configure the various, we configure the transactions in MuleSoft based on these actions. Okay, so how do you implement transactions in MuleSoft? So you can implement it through components like DB connector. You can have a JMS connector, or you can have a try scope. Okay, so these are the components that allow you to have transactions in MuleSoft. Okay, so these components have to be configured, and these are the different configurations that are supported by MuleSoft for transactions. So you can see always begin is one of the actions. So what does this always begin indicate? This indicates that whenever a message arrives into the Mule flow, you initiate the transaction. Okay, so in case we send a request from the client to our Mule application, so the message is received at the source, and as soon as the message is received, a transaction is initiated. So whatever components are a part of that transaction, they will either succeed or fail as a single unit. Okay, so you can see this always begin configuration can be done either in Triscope, or there are supported listeners, okay, like JMS and all, where you can configure this. So these are nothing but various configuration. So if you configure any of the uh, components that supports transactions in MuleSoft to indifferent, it means that that particular unit should not be considered as a transaction. So it's not necessary that every time you add a try block, you want that unit to be considered as a transaction. So in case you have a try block that does not need to be a transaction, you configure it to be indifferent. Okay, and you can also go with always join. Always join configuration means that, so when the message arrives at the component, the transaction is already in progress. Okay, so that's what always join means. Begin or join means that, so when a transaction arrives at the component, when a message arrives at the component, uh, you can either join that transaction with the existing transaction, or you can begin a new transaction altogether. Okay, so based on the scenario that you are working on, you can accordingly configure your components for various transactional actions. So you have a detailed description of these actions in the MuleSoft documentation as well. So, a simple configuration that we usually use is always begin, right? So whenever a MuleSoft message is entering the flow, that particular set of components that are a part of that flow are initiated to be a transaction. So these are the different MuleSoft transactional actions. Any questions?
Shivani, can you explain the beginner join once again?
Yeah. So like I said, for always begin, whenever a Mule message enters the flow, whenever a Mule message, the transaction should begin. That is always begin. So in case of begin or join, when the Mule message enters the flow, you can, if the transaction is already in progress in that flow, you can either join with that existing transaction that is already in progress, or you can begin a new transaction with the message that entered altogether. So that is begin or join. If you select always join, then the incoming message will always join with the transaction that is already in progress.
Got it.
Yeah. And if it is join, if possible, then only if there is an existing transaction that is in progress, join. Otherwise, don't join. Okay, you can only join a transaction with another only if there is a existing transaction in progress. So that is join if possible. So these are the different actions based on which you can configure your transactional actions. Okay, and there are limited components in MuleSoft that support transactions in Mule. Like I said, Triscope, Database Connector, JMS. So these are the limited components that support transactions in MuleSoft, right? Because these are the, like, database component is something that enables you to connect to the external system. Similarly, there can be various connectors that allow you to connect to the external systems. For example, Salesforce connectors. Okay, you can have Workday connectors. So if you're using a connector that allows you to connect to an external system, that is when the transaction and consistency comes into picture. So only supported components in MuleSoft allow you to configure the transactional actions. Okay. You can go with always join also if it is an extended architecture. You like, let's say you have two, yeah, you have two insert components, let's say, and one insert is interacting with one db and another insert is interacting with another db. So you can configure them to always join, so that whatever transaction is in progress, any new message that comes in is that transaction joins the one that is already in progress. No, I'm saying 2 dBs. I gave an example of 2 dBs. The scenario that you are saying is 1 dB and 1 JMS, right? So if you are interacting with 1 dB and 1 JMS, then in that case you can go with always begin and always join. Yeah, you can go with these two. Yeah, that will be rolled back at any point in time in two-phase commit. Um, in case any of the component fails, then it gets rolled back, because the entire all the operations have to succeed for the entire functionality to succeed as a unit, and if it is not, then it will be rolled back. Yeah. Okay. So going forward, we have this okay, but before we go to Bitronix connector, so I want to talk about one more topic that is called as eventual consistency. Okay, so eventual consistency is nothing but bringing your entire system to a consistent state, right? So to achieve this consistency only in case of a XA architecture, extendable architecture, we are going with the two-phase commit protocol. Now, there can be situations where you cannot implement this two-phase commit protocol. Okay. In that case, what options do you have? Um, Anybody, you have anything to pitch in? If not two-phase protocol, what else can we try? What else can we incorporate to achieve consistency in our functionality or in our system? Any thoughts?
Maybe a repeat transaction
Repeat transaction.
for rollback.
Okay. Okay, you don't want to, like, go with these transactional actions at all. Okay, you want to go with a you want to design your application in such a way that um, you don't want you are interacting with multiple systems, and you want to achieve consistency at the end of the day for your system. I mean, towards the end of the functionality, you want to achieve consistency. Even if you go for repeat or rollback, at what point are you going to repeat or roll back, right? So um, so we need to follow a design pattern. Let me give you a
Maybe
two.
Shivani, sorry, I was talking on mute. So maybe we can go for the guaranteed delivery or reliable delivery patterns,
Uh-huh, right. Okay, like.
like maybe using the VM connectors or the what you can say the store and forward mechanism. Okay, so I think by using the um, JMS queue, any point MQ or object store, okay,
Hmm.
anywhere we can store and forward. Okay, make sure we are not going to lose these things.
Okay. Okay.
Yeah, this guaranteed or reliability patterns, or maybe how this can be used. Yeah, maybe I can use what I can say the VM queue. Okay, correct. Like I will
Okay.
store and store into the queue and send the acknowledgement. Then again the different processor which is going like flow is going to subscribe and
But
process.
yeah, that's a see again for that. I think if you are using multiple resources, you will have to incorporate, some complex logic to achieve
Hmm.
the to achieve what you want, right? Eventual consistency. So instead of that, we can follow a design pattern which is called Saga design pattern.
Okay.
Okay,
Hmm.
wherein you have independent local transactions
Hmm.
instead of working with global transactions. Okay, instead of working with a single global transaction wherein different components of your application are interacting with different resources, you can have set of local transactions that fail or succeed together. Okay, that is called a saga design pattern. So in case you want to avoid this two-phase commit protocol, wherein you have a transactional manager, wherein you have VMQs, you use various mechanism to, not lose data, to reinitiate the transaction, or, to define a consistent state in case something wrong happens. So to avoid all of this, you can follow a design pattern which is called saga design pattern to achieve eventual consistency. Okay, so the saga design pattern is, to put it simply, it is a set of local transactions. Okay, so all these set of local transactions either fail or succeed together. So let me give you an example of e-commerce. Okay, so in case of e-commerce, you have three major actions. One second, let me, yeah. uh, okay, so my screen is still visible to you, all right?
Yes.
Yeah. So in case of an e-commerce platform, let's say you have three systems. One is for placing an order. Okay. After placing an order, you go to the payment section where the customer makes the payment. And the third thing is the product is delivered to the customer, right? So there are three things that happen. So one is placing the order, second is paying for whatever you have ordered, and third is the order getting delivered to the customer, right? So let me just write order, payment, and delivery. Okay, so these are independent local transactions. Okay, the order transaction, the payment transaction, and the delivery transactions. Okay, so if you place an order, the next step is payment, and post that you have the delivery. So let us say at some point any of these local transactions fail. Okay, so let's say order, after order you have done the payment successfully, but your order is not delivered due to, whatever real time situation. Maybe there is rain, or maybe your while transit your product got damaged. Whatever reason, you have not received the delivery. So in that case, the delivery has failed. So what this transaction will do is, this transaction will send a message to the order local transaction, okay, saying that the delivery has failed. And based on that, a subsequent action will be taken, compensating action will be taken by the order. So yeah, the logic for that you can define it actually. So if you want the delivery to send a feedback to the payment, you can do that also. Payment flow, you can do that also. So in case the delivery fails, a failed delivery message is sent to the payment service. Okay, then what action does the payment service do? Maybe you can refund the payment, okay, or you can hold the payment, and once the payment is in refund state or hold state, you can send that message to the order transaction. So post which you can either cancel the order, okay, or you can archive the order. So based on a certain event here, each and every each and every service is deciding what to do, and that is completing a transaction. So basically it's like a choreography. It's called choreography saga design pattern, wherein it's called choreography because based on a particular event, a particular response is happening. Okay, so it's like it's like dance. So no, they are dancing to their own tune, like whatever response is coming from the delivery service, that is being sent to payment, based on which payment is doing certain steps. Based on what payment is sending to order is doing certain steps. Similarly, if order is saying that order is successfully placed, then payment is taking the payment services initiating the payment from the customer. If payment service says that payment is successful, then the delivery service is initiating the delivery to the customer. So this is called choreography saga design pattern. Okay, so you can manage set of local transactions that work as a unit, that talk to each other, and based on the communication that they sent out to each other, these are different services. So based on the communications that they send out to each other, a particular compensating action is taken that eventually brings your system to a consistent state. So if the delivery is not done, delivery system talks to payment system. It sends a message saying that delivery has not been done. Then the payment refunds the payment and says that the payment has been refunded to the order system. Order system appropriately changes the status of that order and does the communication to the customer, and eventually this entire system comes to a consistent state. This is eventual consistency choreography saga pattern. Are we clear, everyone, as to what alternative we have in case we don't want to go to a two-phase commit protocol, where we have a transaction manager, and different resource managers that manage different resources. Okay, every functionality can be a local transaction, and these set of local transactions can work as a single unit by communicating with each other.
So in this case, the communication can happen via any queuing mechanism or any other possible alternative, right?
Yes, yes. Queuing mechanism, yeah, the communication can happen through that. Application to application communication can also happen. Internally, inside the application also, you can have different services defined. So,
Okay, so let's say from the order service, you are publishing that piece of information to the payment. So
mhm.
in that case, in your order service code, how do you define the transaction? So it's only for the JMS you would be starting a transaction?
Yeah, you will be starting at, I mean, you, only for this order, I, I mean, once the order is sent out, this transaction is complete. This set of local transaction is complete. See, after it has given out the message to the payment, it is still not in progress. This particular local transaction will complete once it is done, unless it receives another message from the payment saying that it is refunded, or unless it receives a message from the payment, this is complete. So these are independent set of local transactions that work as a single unit.
Okay, so each JMS component within each of these flows, they would be acting as a single individual transaction.
Yeah, there would be individual transactions, local transactions, okay, and they would be communicating with each other to achieve eventual consistency. That is why we are not saying that it is in it's maybe when the delivery is failed, the order might not be consistent with the failure of delivery, because the order has done its job, order has placed, and it has moved to the payment state. Okay, the payment is also complete and it's moved to delivery, but the delivery is failed, which is the last step. So these two are right now not inconsistent with the delivery unless the delivery gives a failure message to payment. So the delivery gives a failure message to payment saying that the delivery has not happened due to so and so reason. Okay, then the payment is initiating a refund and giving a communication back to order saying that this happened. Then the order will change its state. Then these three become consistent. That's why it's eventual consistency. It's not immediate consistency.
Yeah, so in case of a failure, delivery, whatever it would be responding back, that is going to be an asynchronous transaction again, right?
Yeah, that's an asynchronous transaction. Payment need not wait for a response from delivery.
Okay, thank you.
Yeah, yeah, yeah. So this is the choreography saga design pattern. In this design pattern, by implementing this, you are eliminating the problems or the drawbacks of a two-phase commit protocol or the extended architecture protocol. Okay, so you have another saga pattern also, wherein all these three services communicate with a single manager service. It's like your transaction manager. So here it is choreography because these three are communicating with each other. But in case of another saga transaction pattern, you will have order, payment, and delivery communicating with a single manager. Okay, and this manager will decide to do what action to be taken. Okay, so based on the requirement of your project, you can take a call. So if you consider a real-time example, so when you are on the road, you follow the signal, right? You usually, the signal is nothing but your manager. If it says green, you go. If it says red, you stop. If it says yellow, you pause, right? So similarly, this transaction manager is like that. But here in this case, you have no transaction manager. In case of choreography saga pattern, you do not have a transaction manager. The local transactions talk to each other to achieve eventual consistency. So this was one more topic that I wanted to highlight before we move to Bitronix connector. Okay, so Bitronix connector is provided by MuleSoft. Okay, it's like a transaction manager basically. We were talking about transaction manager, right? So this is an inbuilt transaction manager provided by MuleSoft that helps you to recover from interrupted or interrupted transactions on restart. Okay, so you can configure this connector in your global configuration. Okay, so if at all a Mule instance crashes or loses connectivity to a resource manager, okay, in that case, a transaction can fail abnormally. Okay, between the two phases that XA protocol has. Okay, so in that case, a transaction manager is helpful in performing a recovery process. Okay, so you can configure a Bitronix transaction manager. So whenever you are using two database instances in your Mule application, okay, whenever you're using two database instances, so in that case, let's say there's DB1 and DB2, two configurations, you can configure a Bitronix transaction manager in your Mule application to manage a situation wherein any of the resource managers fail to send out a proper communication between the two phases due to any reason, maybe the system crashed or something. So in that case, this transaction manager is necessary. You can also set out explicitly, you can set out the timeout and different properties of this transaction manager. You can explicitly set it. You can even set it through the runtime manager as well. Timeout and all of that you can set. So how to the expressions that you need to use to set the timeout, you can you can go to the MuleSoft documentation. You have all the details as to how you can set the timeout properties through runtime manager. So after you have deployed the application, you can go to the properties tab and you can explicitly set the timeout for the Bitronix transaction manager. Okay. Are we clear, guys, so far? So in the interest of time, can we see a quick demo?
Yes.
Okay. So 1 second. Yeah. Okay. So I have designed a flow. So this is a simple local transaction. Okay. So this is my component, that this is like a resource manager. This component, it interacts with the external database. Okay. So I have an external database which I have created in Elephant SQL. 1 second. Yeah. So this is my instance. So here you can see I have different tables. Okay. So this is my DB instance. I mean, I usually prefer working with Elephant SQL because it's a platform as a service. If you are already using, MySQL on your machine, okay, if you have it downloaded, you can you can create tables and different database instances there also. So if you're working with Elephant SQL, you can, so here I have various instances. You can see I have 2 instances. Okay, right now I'm only working with this instance. Okay, so in this instance, I have about these many tables. So as long as my flow is spanning across this instance only, it is called a local transaction. And you can see that the insert operation is here the component that is talking to my SQL system. Okay. Yeah. Yeah. So in my global elements, I have a database configuration wherein I have given all my configuration details to connect to the DB instance. Okay. So let me take you to the flow. Okay. So I have a transform message here that has 2 variables. One is products and one is B name is nothing but brand name. So this products variable is having 2 attributes, name and price. Both of these values are coming from the query params. Okay. Similarly, I'm taking the brand name value also. This is also coming from the query params, and I am performing a insert operation into my table called product list. Okay. So it will be inserted, and after inserting into product list, I'm performing one more operation wherein I am inserting my data into one more table called copy product list. Okay. After this, I'm having a transform message that is performing a check. Okay. In case the brand is given as Suzuki, I am going to a failure. Okay. I'm failing the transaction, saying that we don't accept a brand name called Suzuki. We only accept any other brand name. Okay. If it is not Suzuki, then the payload will be returned and the insertion will happen successfully. And this is a try scope. It is a transactional component of Mule. And I've set it to always begin. Okay, so this is where you get to set the transactional action. You can set it to always begin, or you can set it to begin or join, or you can set it to indifferent. So by default it is set to indifferent. So if you go to insert component, if you go to advanced, here you can set the transactional action. So insert component of database is also a transactional component. You can either go for join if possible or always join. Okay. So in case you are going with an XA transaction, preferably you can go with always join. Okay. So if the transaction is already in progress, you want the incoming message to be joined with that. Okay. Yeah. So let me run this demo. Okay. So yeah. So here I'm sending name as wizard, price as 8, what is it? Yeah, 80,000, and brand as Suzuki, which is incorrect. So first let's go with the successful brand. Let's say, because in our transform message we have written a condition that in case if it is a Suzuki brand, then we are supposed to throw an error and the transaction has to be rolled back. That's what it means. But I'm giving the brand as Blue Star, which means the transaction should successfully commit. Okay. So okay. Uh, says 200. Okay, 1 minute. Sorry. Uh,
One question, Shivani. So this is a kind
yes.
of sequential transaction that we are doing in our Triscope. So can we achieve the same kind of transaction in like parallel manner? Like let's say if we use this gather gather, can we implement some kind of transaction actions over there?
So usually transaction configurations do have an impact on the various scopes and various components like scatter gather. So when you are configuring transactions, so usually scatter gather has a property of this parallel, or its property is to execute its routes parallelly, right? But when you are having a transaction configuration implemented, in that case, it will not be parallel, it will be sequential. So when you're configuring transactions, right, even a parallel for each loop will work or behave like a for each loop. Okay, if you are having an async flow, okay, that scope, async scope, that scope's behavior will also change if you are having a transaction implemented. So a scatter gather will no longer have the parallel behavior.
Okay, and that gather gather should be wrapped around the Triscope, right?
Yeah, if you wrap it in a try scope and if you are making it a part of transaction, it will behave sequentially. If you have a for each component, for each scope, sorry, if you have a parallel for each scope, usually parallel for each scope is its behavior is to execute parallelly, right? Even if one record fails, the entire execution does not fail. It does not stop. So, but if you are encapsulating it in a transactional logic, then its behavior will be like any other for each scope. So, a detailed explanation of how transactions affect different scopes, like until successful, async scope, and all of these are present in the Mule documentation. So, even the scatter gather, how it behaves when you put it, encapsulate it in a transaction, is also present. So the scatter gather will no longer have the parallel behavior. Okay. Yeah. Okay, so it is inserted successfully. So now I'll go select from product list. So you can see it is added. Geyser 80,000 and Blue Star is added. Similarly, you can select from copy product list also. It is added. Okay. Now, if you add Suzuki here, which is incorrect brand, it's gonna throw you an error, and the transaction is rolled back, which means you would not see it in copy product list. Okay, you would not see it added in the copy product list. At the same time, you would not see it added in the product list. Okay, it will not be there. So which means it is rolled back. So it is a simple demonstration for a local transaction. Similarly, you can have another DB configuration. If you're using a local MySQL, like I already said, please have another DB instance. Here you can see both my insert operations are using the same DB configuration, which indicates that it's a local transaction, right? So similarly, you can have another DB configuration which is talking to another database, which means this database name will change. Here my DB name or instance name is this. Okay, if I'm using another instance, my another instance name will change. Okay, and if I'm talking to a table in that, I also have to configure a Bitronix transaction manager. Okay, you have to configure a Bitronix transaction manager and make sure that in your insert you go to advanced and you select always join. You go to advanced and you select always join. Okay, and also one more thing you need to do if you are going with an XA transaction. So you have transaction here, you select use XA transaction. Okay, do not forget to check this when you are going for an XA transaction. So you can try out the demo for XA transaction wherein you are configuring another database instance. Okay, you will have two configuration. I've given you an overview of how to create a flow for local transaction where I'm having a single database config. You can have another database config and configure your second insert operation to that. And when you are doing that, make sure that you check the use XA transaction option and you go for always join in the resource manager, which is nothing but this insert component. Okay, so that's all from my side. We are already running out of time, so I hope the session was useful to you.
One
There
question.
is a yeah,
Shivani, one question.
someone will
Um,
yes.
yeah, so records and in the batches of 1K. Okay, so let's say
Okay.
ninth batch was failed. Okay, so in that case, I want to roll
Okay.
out. Is it possible to roll out remaining 8K which are inserted already from the database instances? Let it be local transaction or XA. Is it possible?
Yeah, it is possible to roll back those because even the batch processing scope works synchronously when a transaction is applied, when it is in the transaction scope.
Okay, so
So
in that
all
case,
of
should
batch
I go ahead? Yeah, go ahead.
yeah, I was just saying batch processing is also an asynchronous behavior, right? So uh, when you configure transactions, all of these components that have asynchronous behavior, their behavior will be impacted by it. So they will behave to respect the transaction configurations that are set. So in case you have a rollback strategy, in case of a failure, then if your unit is defined like that, if all the 10,000 records have to success, only then it has to commit. And if it fails at some point before 10,000, then it will be rolled back.
So the transaction action for database insert, first one should be always begin, and the second database insert should be always join, right? No
Yeah,
change in transaction
yeah,
action.
no change in transaction action.
Okay, the same thing applicable for extended architecture, right?
Yeah.
Okay, thanks.
So we can discuss more about transactions, Bitronix component, and Saga patterns, and we can have various demos also. But in the interest of time, this is the information. This is the high level information that we could talk about transactions, because these are really important in any project that we work upon. As I mentioned in the beginning, there is nothing that is not a transaction in the real time world, because we don't want to be stuck with any of the responses. We either want a success response or a failure response. So transactions are the ones that help in achieving a definite response. So yeah, this was an overview of transaction management. So if you have any questions, we can spend some time discussing those questions. Yeah. Apart from the session, if you have anything for me, you can ask.
So,
Or
Shivani,
yeah.
yeah, I was asking, apart from the DB connector and JMS connector, anything else that supports a transaction?
Like I said, there can be different connectors. There can be IBM connector. There's IBM MQ that also supports transactions. There is Triscope that also supports transactions, and it depends upon the connector that you are using to connect to an external system. Okay, let's say you are using a Salesforce connector to connect to Salesforce objects, right? So in that case, such components support transactions. Okay, the wherein whichever component you are using to connect to an external system, that eventually has to be at a consistent state. Okay, so these are a couple of examples that usually it is the VMQ, DB, JMS, DB connector, Triscope, IBM MQ, Active MQ. All of these support the transactions.
Okay, thank you.
But but depending upon which external system and which connector, there can be other connectors as well that support transactions. Yeah.
Okay.